Okay, so this is 3.3 coordinate geometry, and we're going to continue some of the stuff that we started talking about on how to look at geometry in the coordinate plane. So our essential understanding for this lesson is that students will understand how to use parallel and perpendicular lines in the coordinate plane. So we actually had several different success criteria for this. I can identify the slope of the line, the graph, I can graph a line in slope-intercept form. I can use slope to determine if lines are parallel or perpendicular in the coordinate plane. I can make conclusions about figures in the coordinate plane using the properties of parallel and perpendicular lines. Or I can write the equation of a line that is parallel or perpendicular to a given line. So these last two items here, these last two success criteria, we're really going to focus on those in the classroom, these two right here. So we're going to kind of just do some of the specifics, skill pieces in the lesson, in the video lesson today, okay? The other thing that I wanted to say was that this should be review from last year, so hopefully this looks like review. So let's get started. All right, so let's talk about a quick review of slope. Remember slope? Slope is how steep a line is. So if I wanted you to describe slope, you might say, you know, a line that's really, really steep or a line that's really, really flat. The slope measures how steep or flat that line is. Okay. Now there's lots of different ways we can talk about slope. One of the ways that we talk about slope is using this expression right here. And that triangle is really a delta, remember? So that's delta y over delta x. And in mathematics and in science, delta means change. So when I write delta y, what I'm talking about is the change in y. So slope is really the change in y divided by the change in x. How much are we increasing divided by, in the y direction, divided by how much we're increasing in the x direction, or maybe decreasing, just depending on the line. I know a lot of you guys have heard the expression rise over run, so it's the same idea. The change in y is the rise, the change in x is the run. And then of course we have a formula for slope, which should look familiar as well. Slope is y2 minus y1 over x2 minus x1. And remember, that's when you're looking at two coordinate points, x1, y1, and x2, y2. It doesn't really matter what you label the points, which one is x1, y1, and which one is x2, y2, as long as you get the points in the right order when you plug them into the formula. So one of the things that I want you to do here is put a nice box around that formula because that's a really important formula. Okay. Over here on the left, I've got the questions lined up for this entire lesson, so make sure you get them in here. One question here would be, how do you find the slope of a line? Any one of these answers is reasonable. And then what are three different ways of representing slope? So you might represent it with delta y over delta x, change in y over change in x, rise over run, or you might represent it with this formula. Now, I know in the past one of the things that you might have done to calculate slope, let's say we wanted to calculate the slope of this line, you could actually plot the points and then count. We went up 1, 2, 3, 4. We went up 4. We went over 1, 2, 3, 4, 5, 6. So the slope of this line would be up 4 and over 6, or 4 over 6, which then would reduce to 2 over 3. So let's do a little practice. Let's find the slope of the line between the points 4, -8 and -2, 6. And again, notice that over here on the left, I've included my exact question exactly as it's written in the example so that you can go back, read this question on the left, and then you'll have all the correct work here on the right to check yourself. So the first thing I'm going to do is rewrite those points, 4, -8 and -2, 6. I'm going to label them. 4, -8 is my x1, or excuse me, 4 is my x1, -8 is my y1. -2 is my x2, and positive 6 is my y2. Now I did those in colors for a specific reason so that you can see and make sure you're plugging them into the right spot in the formula. So let's write down our formula. Slope is equal to y2 minus y1 divided by x2 minus x1. And now let's plug in the points in the appropriate place. So it's going to look like 6 minus a -8, because y1 was negative, And then the bottom, negative 2 minus 4. So we've plugged in our points. Now all we need to do is simplify. So 6 minus negative 8 becomes 6 plus 8. And then negative 2 minus 4 is negative 6. And then 6 plus 8 is 14. So we have 14 over negative 6. Now because we're dividing a positive by a negative, we know our answer is going to be negative. So the slope here is negative. And then if I reduce the fraction, I will get 14 over 6 reduces to 7/3. So my slope here is negative 7/3. Now since it's negative, one of the things I know is that that line is falling from left to right. It's not rising from left to right. All right, so let's review quickly about graphing a line. When we graph a line, one of the easiest ways to graph a line is when it's in slope-intercept form, like this line is here. So you guys all remember from algebra, y equals mx plus b is slope-intercept form, where that number m is what we use to represent the slope, and b is what we use to represent the y-intercept. So whatever we're multiplying x by is the slope, and whatever is the constant, the number that we're adding or subtracting at the end, is going to be the y-intercept. So let's look at our questions on the left here that I want you to know. What is the slope-intercept form of a line? Y equals mx plus b. How can you tell the slope from the equation of a line? Well, you're going to be looking for the number, the coefficient of x. What you're multiplying x by will be the slope. And then my last question, of course, is what is a y-intercept? Well, that's where your line crosses the y-axis. All right, so let's practice a little bit of graphing. Let's graph each of these lines. Y equals 3x minus 4, 1/2 x plus 3, and negative 2x minus 1. And again, write all of those equations over here on the left. Now what I'm going to do is use a different color to graph each of these lines. And in your notes, I'd like you to do the same thing so you can really tell which equation goes with which line. And if you can't do that, then just draw 3 separate graphs and label each of the 3 separate graphs with their correct equation. Okay, so we want to graph y equals 3x minus 4. So the first thing I'm going to do is look at the intercept. The intercept is negative 4. So let me get my pen here. And what I want is a blue line. So I'm going to start with the intercept at negative 4. And remember, that's the y-intercept, right? So we're going to go down 1, 2, 3, 4. And right here is my y-intercept. So I'm going to plot that point. Now I'm going to use the slope. The slope is 3. Well, wait a minute. What does that really mean? Well, think about it as rise over run again. So that would be in fraction form 3 over 1. So from there, I'm going to go up 3 and then rise and run 1. And then I'll put my next point. Keep doing that. Keep using the slope to get more points. So from here, up 1, 2, 3 over 1. And again, we'll do it one more time because we've got room in the graph. Up 1, 2, 3, and over 1. So now I've got enough points, I can make the graph of my line. Okay, so we'll start here, go through all those points like this, and then one thing you really should do is make sure that the line that you graph doesn't go through just the points that you did, that you plotted, but it's a line, right? It continues in both directions infinitely, so let's make it look like that. And my line should be blue so that it matches up with my equation. And it should have arrows at both ends. So I'm going to do that using my smartboard, but of course you guys can just draw arrows at the end of your line. There we go, we got it. All right, so let's do the next one. Y equals 1/2 x plus 3. All right, this time we want red. I might try to make these a little bigger so you can see them better. Okay, so we have 1/2 x plus 3. So the first thing we're going to do is go to positive 3 on the y-axis. That's my y-intercept. And my slope is positive 1/2. That tells me go up 1 over 2. Plot a point. Up 1 over 2. Plot a point. Up 1 over 2. Plot a point. Now, since I'm running out of room going that way, we're going to go the opposite way. Instead of going up 1 over 2, we're going to go down 1, back 2. And that's going to give us room to get more points. Down 1, back 2. All right, now we got it. Now let's get our line again, and we will connect the dots. You guys should use a straight edge to do this, please. And let's make that line red so we can make sure we know which equation it's going to. get arrows at either end because it is a line that extends infinitely in both directions. Awesome. All right, we got it. All right, so just to recap here real quickly, when I'm graphing a line, we want to start with the y-intercept and then use the slope to plot more points. And if you need to pause and write that down because you don't, it's a little fuzzy from last year remembering how to do this, write down those directions. Plot the y-intercept first, then use the slope to plot more points. All right, let's do this last equation here. This one's a little bit different because the slope is negative. And again, think about the slope as -2/1. So we can think about that as a rise and a run. So y equals -2x minus 1. My y-intercept is -1, so I go down -1 on the y-axis. Again, let me make that a little bit thicker so we can see it. -1, and then my slope is -2. So that means this time, instead of going up 1/2, I'm going to go down 1/2. And when you're going over, you're always going to the right. So down 1, right 2, down 1, right 2. Now we have to kind of go in the opposite direction. So up 1, back 2. I know that a negative slope is always going to be falling from left to right. So I'm going to use that as a check to make sure that my slope looks correct. All right, and then what we've got to do is just connect the dots here with my line. Awesome. We'll make it green just so we know exactly what it's supposed to look like, which equation goes with which line, and we got it. All right, so that's our quick recap of how to graph the equations of a line. Awesome. Now let's talk about some specific relationships between slopes. One thing we're going to be looking for, especially when we're graphing geometric figures, is sides of figures that are parallel or sides of figures that are perpendicular. So we have to be able to tell whether two lines in the plane are perpendicular or parallel. So let's start with parallel lines because they're the easiest. Parallel lines have the same slope. And of course that makes sense because slope measures how steep a line is. So if two lines have the same steepness, then they're never going to intersect and are going to be parallel. So one way I represent that is M1 is equal to M2. That just means the slope of the first line, the 1, is equal to the slope of the second line, the 2. So on the left here, what is true about the slopes of parallel lines? What's your question? Now what about perpendicular lines? Perpendicular lines have what we call opposite reciprocal slope, or sometimes people call it negative reciprocal slope. And what that means is if I have two slopes, M1 and M2, M1 will be the reciprocal of M2. Remember, reciprocal means flip or to do a 1 over, so 1 over M2, but it will be the opposite of that, or in other words, negative. And I think this can be a little bit confusing, so let's represent it another way. Let's say that the slope of M1 was A over B. If that's the case, and M1 and M2 are perpendicular, the slope of M2 will be negative B over A. So see, we just flipped that fraction and made it negative. And just to clarify, let's look at one more example.
Yeah.
All right, so for example, let's say line N had a slope of 5 over 7, and line A had a slope of negative 7 over 5. Then I have the wrong symbol in here. Let's fix that. There we go. I would say that line N was perpendicular to line A. See how we have 5 over 7 and then negative 7 over 5? Their slopes are opposite reciprocals. Okay, so let's look at an example and let's graph these three lines. Y equals 3/2 x plus 1. So that has a y-intercept of positive 1 and a slope of 3. Let's get the right color here. It should be blue. So y-intercept of 1 and a slope of 3 over 2. So we're going to go up 1, 2, 3 over 2. Up 1, 2, 3 over 2. Up 3 over 2. And then we can even go down 3 and back 2 to get a few more points on the line. Okay, and so then we will connect the dots here. Awesome, and we'll make that line blue because it should be blue because it goes with the blue equation. Okay, so what we're going to be doing here is graphing these three lines and then looking for the relationship between them. Now we want to graph the next line, which is 3/2 x minus 2. So it has a intercept of -2, and the slope of 3/2 again. So up 3 over 2, up 3 over 2, up 3 over 2, etc., etc. Then we go in the other direction, down 3, back 2, down 3, back 2. There we go, we got it. And now we're going to connect the dots and make our line. Awesome. All right, we got one more to do, -2/3 x plus 1. So now let's get our green pen. Y-intercept of +1. So it actually has the same y-intercept as the blue line, but the slope is -2/3. So now we're going to go down 2 and back 3. Or excuse me, down 2 and over 3. Down 2, over 3. Down 2, over 3. Or up 2 and back 3 if we wanted to get some points going in the opposite direction. All right, so now let's connect the dots there. And then we'll make the line the right color. And let's make a comparison. Looking at these lines, what do you notice about the relationship of the lines? You should see that the blue line and the green line are perpendicular. The red line and the green line are perpendicular because they have opposite reciprocal slopes. In other words, they're making a 90-degree angle. The blue line and the red line are parallel. And that, of course, makes sense because these two guys have the same slope. All right, so a couple other really quick examples. Let's find the slope of a line that's parallel to y equals 2x plus 5. Now remember, what we're looking for here with parallel lines is we're looking for the slope. Well, the slope of this line is 2, so the slope of a line that would be parallel would be 2. So the slope of a line that's parallel would be m is equal to 2. Okay, we got it. That'll be our parallel slope. What about the slope of a line that would be perpendicular to y equals 2x plus 5? Well, again, the slope here is 2 over 1. So if we wanted the opposite reciprocal slope of that, we have to flip it and make it negative. So the opposite reciprocal slope would be negative 1/2. And instead of y, I'll make that an m. So my perpendicular slope will be negative 1/2. Okay, oh, I didn't put it over here, but you should. Find the slope of a line parallel to 2x plus 5. Find the slope perpendicular to y equals 2x plus 5. So get those questions in here on the left. All right, so we're almost done. I just wanted to review a couple things about horizontal and vertical lines. Horizontal lines and vertical lines are actually really easy to draw, but they get confusing because they're not really in the standard form of y equals mx plus b. So what you have to remember is that when you have just y equals or x equals, that's going to be either a horizontal or a vertical line. So how do you tell which is which? Well, if you have something in the form of y equals 2, like this first equation, that means that the y coordinate is 2 everywhere. So let's go to where we might start with our y coordinate on the y-axis. Right here is a y coordinate of 2. But look, here that point has a y coordinate of 2. This has a y coordinate of 2. This has a y coordinate of 2. So if you look at every single place where we have a y coordinate of 2 and we plot all those points, our line ends up being horizontal. So let's graph that horizontal line. There we go. And let's make it the appropriate color. So anytime you have something in the form of y equals a number, it's going to create a horizontal line. On the other hand, if you have something in the form of x equals a number, for example, x equals -3, that means the x coordinate is going to be the same everywhere. So let's go to the x-axis and find -3. Now there's a whole bunch of other points that have an x coordinate of -3, like all these points that I'm plotting right now. Right? This is the point -3, 6. This is the point -3, -5. So you can see, if you consider all of the points that have an x coordinate of -3, we get a vertical line. Okay, so that's just a quick review of how to graph horizontal and vertical lines. All right, I think we've got everything that you need to know. So what I want you to do now is take all that information and write a 3 or 4 sentence summary of the information. You should cover slope, graphing lines, parallel lines, perpendicular lines, and horizontal and vertical lines, because then we're going to use all that stuff to identify some relationships when we get back to class on Wednesday.